In this video, we're going to look at how we can do different operations with polynomials. We're going to start with addition and subtraction, and this is essentially just combining like terms, except in the end, we'll write our answer in standard form. So remember that in order for two terms to be alike and to be able to be combined, they have to have the same variables raised to the same powers. And you'll notice now that maybe it's a little different than our previous combining like terms because I've got whole polynomials grouped in parentheses that I'm going to be combining. So the first thing we want to do is just make sure we do any necessary sign changes. So if I look at this first example, I'm just adding these two together. So when I'm doing addition, I can ignore the parentheses because they're not going to really change anything. When we look at subtraction in a minute, the parentheses are going to be super important. But for now, since it's just addition, nothing really happens. So now I'm going to look for terms that are alike that can be combined. So the first thing I see here is 4x squared. So I want to look for any other x squared terms, and I happen to have negative 6x squared. So when I put those together, 4x squared minus 6x squared, we subtract the coefficients, so we have negative 2, and then we bring the x squared over. If I keep going, I have plus 7x to the fourth. I look, and I have minus 4x to the fourth. So those are like terms. So positive 7 minus 4 is positive 3, and we bring the x to the fourth. When I do addition or subtraction, the exponent on the variable does not change. Remember, those exponents represent repeated multiplication, so I'd have to multiply or divide in order to make changes there. Then we keep going down our line here. We have a minus 7x, and then we have positive 7x, and those terms actually cancel each other out to 0. So our last step here is going to be to make sure that we put our answer in standard form. So the degree of my first term here is degree 2. Degree of the next term is degree 4, so I actually need to flip-flop these. And when we do that, we want to make sure we keep the sign with the term. So this was positive 3x to the fourth, so I'm going to make sure it stays positive. And then this was negative 2x squared, so I want to make sure that stays negative. So this is my final answer. If we wanted to name that, that would be a fourth degree binomial. For the next one, when we see subtraction here, we need to be really careful with our signs. And oftentimes what I'll do is I'll rewrite it just so I know that I'm doing everything correctly. So my first polynomial is going to stay the same because nothing is changing there. And then I want to make sure that I subtract every term here. So I'm going to distribute that negative through to every term. So it becomes minus 2x squared. And then when we subtract negative 7x cubed, that turns into addition. So we have plus 7x cubed. And then minus negative 1 becomes plus 1. And now we do the same thing that we did before, where we look for like terms. So first up, I have 8x squared, so I look for any other x squareds. And I've got this one here. So 8x squared minus 2x squared is just 6x squared. Next up, we have a constant. So we've got minus 7. And I look for other constants, and I have a plus 1. So negative 7 plus 1 becomes negative 6. And then we just keep going down the line. So we have minus 5x, and there's actually no other x terms that we can combine that with. So it's just going to stay minus 5x. And we keep going for that last one. We've got 7x cubed, but nothing we can combine that with, so that one's not going to change either. The last step here is to make sure we put this in standard form. So I've got degree 2, degree 0, degree 1, and degree 3. So degree 3 comes first because that's the highest one. This is positive, so it's going to stay positive 7x cubed. So that one's done. Then I go to degree 2. This one's also positive, so it's going to be plus 6x squared. And I've got degree 1. This one's negative, so I need to make sure I include that negative sign. And then we have another negative, so we want to make sure we include that. So in standard form, this would be our answer, and that would be a cubic polynomial. When we start to look at multiplication here, we're going to look at what happens if we multiply just with one term, so a monomial times another polynomial. A little bit later on, you'll look at what happens when we multiply polynomials together, so multiple terms by multiple terms. And really all this is an application of the distributive property. So this is the same question essentially as 2 times 3x plus 5, right? We distribute the 2 to each term, except now the terms are a little more complicated, and we have to pay attention to those exponent rules. So the first thing I'm going to do is 2x squared times 3xy cubed, and we do the same thing as when we did our exponents. So we do the coefficients. 2 times 3 is 6. X squared times x to that hidden 1, so 2 plus 1 is 3. And then we have just the y cubed that's going to get multiplied in there. Then we do the next one, and the same thing happens. So 2 times negative 2, we start with the coefficients. X squared times x squared is x to the 4th, and that's the last term, so we're done with that part. And then we move on to the last one. So 2x squared times y, there's the coefficient of 1 here, so that becomes plus 2, and then x squared, and then the y. And if we check out our degrees here, make sure that 4 actually looks like a 4, we see that we are actually good to go. It keeps connecting. In our order. So this is degree 6, degree 4, and degree 3. So this can actually be our final answer here. Sometimes it'll work out that it's in order, sometimes it's not. You just always want to check. Go ahead and pause the video and try the next multiplication on your own. All right, so again, we're just distributing coefficients by coefficients, x's by x's, y's by y's. We use our exponent laws for multiplying. And when we wrap that up, we end up with a monomial of degree 8, another monomial of degree 8, and a monomial of degree 9. So the degree 9 has to go first, but then after that, since there's a tie, you get to pick the order that they go in. So I just kept it in the same order that it was here. Sometimes you'll see people prefer to go kind of like alphabetical after that if there's a tie. So since this was x to the 4th, sometimes you'll see that written first before you have an x to the 3rd. I'm not really super concerned about that as long as the degrees are in order. Once you hit that tie, it doesn't matter. And last up, we're going to look at some division, and this also draws back to our distributive property. So I am going to basically split this up into 2 fractions because they're being added with the same denominator. So I'm going to write this as 15 x to the 8th y cubed over that denominator of 3x to the 7th y squared plus the 30x to the 7th y squared over 3x to the 7th y squared. And then we're going to go ahead and simplify anything that we can. So here, in our first fraction, 15 over 3 is 5. X to the 8th divided by x to the 7th, we subtract the exponents, that's x to the 1st. Y cubed divided by y squared, again we subtract, so that's just y. And then we do the second fraction. So 30 divided by 3 is 10. X to the 7th divided by x to the 7th is 1. So this is really 10 times 1, but we don't have to write that. And then y squared divided by y squared is also 1. So for this one, we kind of luck out. And we can keep this in this order. We don't have to do any rearranging. And our degree here, we have 1 plus 1, so that'd be degree 2 for the first term. So that's a quadratic binomial. You can also do this kind of keeping it all together when you see those common factors. So if I take out the 3 from 15, that becomes 5, and from 30, that becomes 10. And then I do the x to the 7th, so that completely cancels out, and this just becomes x to the 1st. And then we do the last one, and the y squared completely cancels out the y squared, and that becomes y to the 1st. So you can do it that way if you want. You just have to make sure that you do it with all the things being added and subtracted in the fraction. So go ahead and pause the video and try the second one on your own. Alright, so in this one I kind of kept it all together rather than splitting. Again, it's up to you how you want to do it. I've highlighted the terms that simplified together. So the coefficients 40 and negative 30 can each be reduced by that factor of negative 5. So you just need to be careful with your signs here. That gives us the negative 8 and the positive 6. And then we did the x squareds in blue. So x squared divided by x squared, that just cancels out to 1. Then we have x to the 4th divided by x squared, gives us that x squared left over. And then we do the y's. So y to the 5th and y cubed, both reduced by just y to the 1st, gives us y to the 4th and y squared. And in this example, we ended up with degree 4. So that's good to go. Remember, if there's a tie, the order does not matter.